Welcome to Electronics Bit by Bit. I'm so sorry for not posting regularly. I've been really sick and I've been working really hard to deal with that. So my posts may be a little less frequent, but I just bought my first Arduino, so hopefully I'll make some fun stuff with that as I start to get better. So this week we're talking about encoders and decoders. Before we do that, we need to bring back the concept of binary codes. Binary codes are the language of computers. Decoders take encoded data and convert it back into its original format, or a format that's more understandable by humans and other systems. Encoders work like a translator, which means that it takes information in one form and converts it to another a form that's easier for computers to understand and work with. Imagine if you had a bunch of words you wanted your computer to process. Dealing with each word directly can be hard for computers. So this is where encoders come in, where we take the words and assign them a unique numerical code. An example of this is the octal to binary encoder. The octal system produces numbers in base 8. Therefore, each number is produced by assigning it 8 digits to represent numbers. These digits are 0 through 7. Each digit in an octal number can represent a different power of 8, starting from the rightmost digit. In computing, octal numbers were historically used to represent groups of 3 bits, since 2 to the power of 3 is equal to 8, making them convenient for representing and reading binary data. So by using this encoder, we can turn these octal digits into binary digits consisting of 3 bits of ones and zeros. You can see in the truth table that the octal number system is represented by 8 columns, Y0 all the way to Y7. Each column is assigned to a specific number in the octal system. For example, Y0 is equal to 0 and Y7 is equal to 7. Each value is being called upon when the corresponding column has a 1, i.e. that column is active. Remember, only one input can be active at a time when you have an encoder. When multiple inputs are active at the same time, it produces an unusable output. Using a priority function, we can get the circuit to return the value of the highest input that is active. If you'd like me to elaborate more about encoders with priority functions, please let me know in the comments. Now I'll get back to our current example. Now that we've gotten our Boolean functions from our truth table, we can build this circuit. Let's get building! Now we're going to talk about decoders, which do the opposite of what encoders do. For example, in data compression, an encoder might compress a large file into a smaller one for storage or for sending off somewhere. Then the decoder takes this compressed file and decompresses it back to its original form when needed. When we're working with decoders, only one output column can be active for a unique combination of inputs. Considering that, we can use our truth table here to come up with the Boolean functions for this 2 to 4 encoder. Given this, we can build our circuit. That's all for this week. See you later.